From the energy sciences area, we have Alexander Pattinson.
Have you ever been stuck in your office doing some really long, boring, repetitive task and wondered, why can't the computer just do this for me? Scientists certainly know what that feels like, especially when we're running our experiments. Take my work, for instance. I work with electron microscopes, using high-energy electrons to study the arrangement of atoms in materials. Cool, yes, but taking data from them is a really long, boring, repetitive process. Move, take an image, move, take an image, over and over again. Now, admittedly, moving and taking images are simple operations for computers to handle. The problem comes in deciding where to move and what images to take. Not every bit of a sample is useful, so we want to be selective, focusing only on what's interesting and disregarding the rest. Interesting, however, is often a rather difficult concept to explain to a computer, especially in microscopy. Imagine that you're looking at my hand, for instance, and you want to take images of all similar particles. Well, it's fine if your particle exactly matches your reference image, but what if it's at a different orientation? What if it's smaller or larger? What if one of the fingers is broken off? Ordinarily, each one of these different possibilities would have to be individually programmed when you're designing your program, which is just more trouble than it's worth. That's why us microscopists tend to resign ourselves to doing the long, boring, repetitive task of taking data manually. But fear not, there is a solution. Unlike normal computer programs, artificial neural networks are really good at recognizing images for two reasons. One, unlike normal computer programs, they see objects as collections of features and don't rely on exact matches to reference images. Two, they're a form of machine learning. They teach themselves how to think rather than being told how to think by a programmer. This means that they can dream up brand new algorithms that us humans might never be able to imagine, all without us ever having to write a single line of code. So how do these networks help me with my microscopy? Well, if I provide images of my particle of interest in all its different possible configurations, a neural network can learn how to recognize all these different configurations. Then, when I look at a large area of a sample, my neural network can pinpoint all these particles of interest and instruct the computer to zoom in for a closer look. Once it's done with this area, it can move on to the next area and do the same again, and the next, all without me ever having to be in the room. So there you have it. Neural networks are capable of making intelligent decisions in the heat of an experiment, automating the entire process. And just like that, the long, boring, repetitive task of taking data is a thing of the past.